thanks for joining me today where I'll be solving a trig substitution problem. So having said that, let's begin. Before we even attempt at solving the problem, there are just a few things we need to know. Like any other trigonometric problems, it always usually involves a triangle, in this case, the right triangle. The sides are usually labeled as A, B, and C, as you can see in this picture. From this point, it's easy to recall the Pythagorean theorem, which states a squared plus b squared equals c squared. Now, using some simple algebra skills, we try to solve for the different variables, like c, b, and a. C equals to radical a squared plus b squared. B equals to radical c squared minus a squared, having subtracted a squared, and A equals to radical c squared minus b squared. The main trigonometric problem involves theta, which I will explain later on as I'm solving the example. The example states that we have to integrate radical 5 plus 4x minus x squared dx using trigonometric substitution. The first step of our solution is to actually complete the square, which will make our lives much easier. To do so, I removed negative out of the function, which will leave us x squared minus 4x minus 5 in parentheses with a negative on the outside. If I divide negative 4 by 2 and square that, I would get positive 4, which means in order to get to negative 5, I have to subtract 9 from 4. The completed square looks like this, and all that's left to do is to multiply the negative back into it. Now we have a new function to integrate, which looks like a square minus a square under a radical, which is similar to the original variables we solved for. Since it's a negative, we're going to assign the variable a as radical 9 minus x minus 2 squared, which coincidentally leads to having x minus 2 and 3 as the other legs of the triangle. Using theta, we are able to derive sine theta, which is equal to x minus 2 over 3, which will lead to x being equal to 3 sine theta plus 2. dx of that will equal to 3 cosine theta d theta. Cosine will be equal to rad 9 minus x minus 2 squared over 3, which will lead to 3 cosine theta equal to radical 9 minus x minus 2 squared. Now we get to the actual substituting. As we saw before, radical 9 minus x squared minus 2 squared gets substituted with 3 cosine theta, and dx gets substituted with 3 cosine theta d theta, which will give us yet another new function to integrate. When we multiply things out, we get 9 integral cosine squared theta d theta. In order to successfully solve for cosine squared theta, we have to refer back to our half-angle identities, which state that cosine squared theta equals to 1 over 2 times 1 plus cosine 2 theta. When we replace, we get 9 integral of 1 plus cosine 2 theta over 2 d theta, which when we take out the half, we get 9 over 2 integral of 1 plus cosine 2 theta. Now it's time to integrate, which we do by separating the integrals. This gives us 9 over 2 integral of 1 d theta plus 9 over 2 integral of cosine 2 theta d theta. We multiply the second integral by 2 because later on it will give us just a nice form. When we finally do integrate, we get 9 over 2 theta plus 9 over 4 sine 2 theta plus c. We cannot leave sine 2 theta as is, so we again refer back to our double angle identity, which states that sine 2 theta equals to 2 sine theta cosine theta. This replacement gives us 9 over 2 theta plus 9 over 4 times 2 sine theta cosine theta plus c. We can cancel out a 2, which finally results in 9 over 2 theta plus 9 over 2 times sine theta, cosine theta, plus c. Now all that's left to do is find what sine theta, theta, and cosine theta equal to, which we can do that by referring to our original derivement of cosine theta and sine theta. After the final replacement, we get this, which we tidy up with the 9s and the 3s and another 3 to get this form of the answer. Again, we simplify one more time by replacing back the original unsquared function, and we get finally 9 over 2 arc sine x minus 2 over 3 plus x minus 2 over 2 radical 5 plus 4x minus x squared plus c. If you are interested in learning how the original U substitution works, I have made a video for that, in addition to another one about curve sketching. If you click on the appropriate boxes, it will take you to those videos. Thanks for watching this one, and have a nice day.